Now, let's demonstrate the overall functionality of the device. First, when we change only the distance between the user and the device, the brightness of the lamp changes continuously. The closer the user is to the device, the brighter the light will be. When we only change the user's angle relative to the device, the color of the lamp changes continuously.
As an initial simulation, a cylindrical DRA with a permittivity of 10, a radius of 23 mm, and a height of 15 mm is used. Based on the optimized design, a prototype was fabricated and measured using network analyzer. The china is designed using F4B substrate material, and the cylindrical dialect is made through 3D printer using a wind preprime AP-S 1000. The china is coupled by slot etched on the ground plane. The microstrip line is printed on the other side of the substrate with a permittivity of 3, and the thickness is 3 mm. The simulated reflection coefficient of the DRA unit shows that a bandwidth from 2.3 GHz to 2.54 GHz is obtained, covering the whole NSM band. In the measurement, the reflection coefficient shows that the bandwidth agrees reasonably with the simulated result. Afterwards, an array is formed by 4 DRAs with a mutual distance of 60 mm between each element, which corresponds to half wavelength of the center frequency. The isolation between the antennas is about 15 dB to detect the beam steering ability of the DRA array. The envelope of the scanning gain is also simulated. In the radar system, the DRA array will be applied to detect the distance and the angle of the user, using map algorithm, beamforming, and FMCW. To avoid the impact of transmitting antennas as much as possible, the receiving antenna is placed below the DRA array.
Pluto SDR is a sophisticated device that can work in duplex mode with independent receiving and transmitting channels. There are several reasons for why we choose Pluto SDR as our receiver and transmitter. First, after our continuous research and exploration, we find a difficulty in making a device which can effectively process the signal we transmit and the echo we receive with simple filter. In this case, Pluto SDR can satisfy lots of RF applications. Second, MATLAB supports the configuration of Pluto SDR. This can help us easily achieve information exchange between computer and Pluto SDR. Third, Pluto SDR is small and can be easily put into closest pocket or backpack. We can learn and explore RF systems at different times and on different devices.
Our code can be divided into 3 parts. In the first part, we realize the transmitting and receiving of the antenna signal by controlling Pluto SDR. After signal processing, we can obtain the distance of the target. The second part is the mapping algorithm we designed. When the distance information of the environment is obtained, the algorithm will compare 2 scanning results to locate the moving target. The third part realizes the control of the light. The distance and angle information of the target will be converted into electrical signal. Then the color and brightness of the light will change.
The hardware circuit is divided into two parts, which are printed on these two different circular PCBs. The black one is designed to place the MCU, the serial ports, the power supply, and man-machine interaction modules. And the white one is designed to place LEDs, and we choose to use the red, green, and blue LEDs to simulate all colors. These two PCBs can be connected in this way, and it is perfectly adapted to this lampshade like this.
However, in fact, the device functionality we demonstrated in the first part was just our expectation. We encountered a very difficult problem when implementing it. We ignored the delay problem of running MATLAB when using this method. After several runs, we found that even for the same device, the same line of code, each time using MATLAB to run, the time is different. For the time-sensitive device like ours, this problem is fatal. It directly causes that we can't get the correct distance result, and we can't realize the beamforming of the transmitter through the time difference, even if the method and procedure are correct. Due to our late discovery of this deadly problem, we still do not have a suitable solution, but we will continue to explore until this problem is solved.